And I have to tell the crowd that we had a joint project a very long time ago. I don't even remember the year, but we are very happy to have Matthew in our department again in the form of a seminar this time, and we are looking forward to the further interactions in the future. Hello, I'm Hayriye Eşbah, the director of the Landscape Architecture Department at ITU. This is the last seminar of our fall Thursday seminar series, and we had hosted wonderful names, and we had really joyful seminars given by Rafi Segal, Garrett Doherty, Jala Maksumi, and Ludovic Ballion 2 weeks ago. And today we are here to listen Matthew Bradbury's exciting interactions with the landscape in his neck of the world, which is the New Zealand, a very far geography to us, but very interesting one. The title of the seminar, the Matthew seminar, will be Water City, and I would like to read his bio now. Matthew Bradbury is an associate professor at the School of Architecture, Unitec, New Zealand, and program leader of the Master of Landscape Architecture. Matthew is a principal in BMLA. The practice specializes in integrating landscape infrastructure and urban development. He has recently completed a book, Water City, and I recommend it to everyone because it includes a very good set of practical strategies to address climate change. The book is published by Routledge. Matthew sees landscape as a remedy of certain problems, and he argues that making a city resilient to climate change will involve questioning the way we design and build and the way in which we retrofit existing cities. Therefore, we need a new urban design process that puts the remediation of environmental issues first, hence prioritizing landscape over the traditional urban plan. So we are looking forward to listening to the strategies Matthew will present to us today, and the floor is yours now, Matthew. Thank you again.
Thank you very much, Professor. And again, apologies for making up the time. I just not quite sure what happened, but I'm super grateful for this opportunity, and looking forward to hopefully being able to talk to you. Hopefully it's not just going to be me talking, because that's very boring. So I'm really looking forward to your ideas and your questions and your thoughts, because that's really what I think these things are all about. So I guess I'm going to talk a little bit about the book, and I guess it's more kind of putting some sort of propositions to you, and then looking at some case studies. So yeah, again, just really interested in your thoughts. Okay. Yeah. Okay. So kia ora whānau. Yeah, my name is Matthew Bradbury, and I guess my background's sort of between disciplines. I kind of trained as an architect, then did my master's in landscape architecture, and then did my doctorate in urbanism. So I'm kind of across disciplines, and I guess that's given me kind of perhaps a kind of way of looking at things from a slight angle, and looking at some of these kinds of issues that we're engaged in, from a number of kind of viewpoints. So this is a book which I completed beginning of the year, Routledge, and it's really a kind of look at how we can rethink our cities and the way our cities are kind of designed within the kind of light of climate change. I guess the thing I'm specifically interested in is flooding and what we call pluvial flooding, which is flooding from the hinterland. So I mean, obviously lots of people are kind of interested in, there's lots of bits of climate change, but that's the sort of bit that I'm kind of I seem to be kind of falling in. So I guess I won't labour the point, but I'm going to suggest there are two sort of we're in the kind of two great truths, I guess, in the world at the moment. First of all, climate change, which I kind of won't kind of labour, because you know all about it, and you know what the kind of consequences are. So the environmental consequences. And then the other, I guess, great truth is a particular model of urban design that or way of thinking about the city that we're in. And again, sort of apologies, I'm really kind of this is more from a kind of Anglo kind of point of view, but and so I guess what I'm interested in these two positions, these two kind of ways we think about the world. Is it, do they, can they kind of work together, or are they actually incompatible? So so this is just examples of kind of weather events in New Zealand. So this is a town called Hastings, just had these floods at the beginning of the year. This is where I come from, city of Auckland, Tamaki Makaurau, and this is a kind of a drive, a kind of a scenic road that runs around the edge of the city and is flooded on occasions with storms. And then these are kind of predicted sea level rise maps again for my city. I'm sure you've seen all these things lots of times. And gradually in New Zealand, we're actually realizing that there is going to be a big problem with climate change, and it is going to have an impact. And this stuff is not, I mean, we've been talking about it for a long time, but it's actually kind of filtering down, and people in New Zealand are actually kind of starting to think, well, what exactly are we going to do about this, and what are the things that we can do to kind of stop things like flooding, sea level rise. We also have a big problem losing biodiversity in New Zealand. We lost a huge amount of biodiversity just with European settlement. Climate change is also going to mean a great loss. Urban heat island. I mean, you guys know all this sort of stuff. Stormwater. Okay, so that's we all know that, and there's lots of people kind of exploring that. I guess the other sort of great kind of truth we have is a particular urban model, which goes under lots of titles, but let's call it compact cities, one of them, and I guess this. The proponents of this kind of model say, well, this, yeah, and we can understand this. It's a reaction against the American kind of suburban model, where you have attenuated services. People live miles away. We've got terrible traffic. We all know the problems of suburbia. So compact cities are kind of the model, and these are the things that it's going to be good. Short distances, reduce pollution, you get rid of cars, everyone rides bikes, it's higher density, we have better walking, more, blah 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 blah. And there's enormous literature about that. I'm sure you all read lots about this. I'm sure you all kind of understand this kind of model, and lots of pictures of how successful this model is. But I guess what I'm kind of interested in is, and I guess this is one of the kind of questions in the book, is compact city, great on kind of lots of levels, but when we look at the effect of climate change, when we look at the kind of especially things like flooding, the increased rainfall, the urban heat island, loss of biodiversity, especially those kind of environmental things. This, does that compact city urban model allow for the environmental effects of climate change? Does this highly dense, highly impervious urban model, is it capable of being resilient to these kinds of effects? I guess that's sort of in very, very broad terms. That's the kind of question I think that I think is kind of interesting. So a lot of people would say, well, there is already, a practice, a body of work in which those kinds of, problems, especially rainfall, can be ameliorated, those effects, and so, again, you will know all this sort of stuff. The treatment train, and the whole kind of idea of these incremental measures which you can insert into an existing city, and these things will help. Well, in the first instance, of course, they're going to help with stormwater. That's what they're kind of were invented for. But people are claiming that these will also help with the effects of climate change. They will also help with the effects of increased rainfall, increased contamination. We can use these things: green roofs, the swales, rain gardens, wetlands. We can use this kind of these sort of measures also for climate change. So and that's, again, a very interesting discussion, and there's a number of studies which are kind of questioning it. So I won't go into kind of detail, but there's a number of people looking at, well, with increased rainfall, we're getting increased contamination. Are these kinds of remediation measures that we use, are they really going to be able to kind of, are they going to be able to work? Soil, green roofs quickly become saturated and stop working. Rain gardens, porous paving, all these things can become overwhelmed by these, by intense rainfall. And so, the efficacy of these kinds of measures, faced with the kind of, what's going to happen with climate change, I think that, I guess there's a kind of a question mark around whether these kind of measures are actually going to kind of work. So, I guess the next kind of question is, well, these measures, which we call structural stormwater or structural kind of measures, if these measures are not going to be effective or are not going to ameliorate the kind of problems of climate change, then what will? Are there any other kinds of ways of doing this? And I guess that's what kind of the books, well, that's what I'm interested in, that's what the kind of books kind of interested in, and I'm very interested in what you think. But so I guess we then sort of need to look at maybe kind of a larger, more holistic, more landscape way of thinking about the city, and about how the effects, these kind of climate, these environmental effects of climate change are kind of going to play out. And I guess what I'm kind of suggesting is that it's actually the urban plan. It's actually the actual city plan itself is the thing that we should really be kind of looking at. We shouldn't be, I guess what I'm suggesting is we shouldn't be I guess the compact, not denigrating the compact city model, but I think we should be looking at that kind of compact city model and just saying, yes, it is great. Yes, it is. It does lots of good things for us. It, in terms of cutting down car dependency, in terms of reducing carbon, lots and lots of good things. But there, to my mind, there's a kind of question mark about its about how it's going to cope with some of the environmental effects, especially things like flooding. And I guess what I'm suggesting is the sort of the techniques we've got so far, these kind of treatment tray and so forth. I'm just wondering if they're going to be effective. So what I'm suggesting, we need to think about this bigger thing. We need to think about this bigger kind of picture, and start thinking about the city as part of these larger kind of environmental systems. And so the city is not, just a kind of fixed urban form with these interventions, but it's actually, this larger interconnected kind of system where all these kinds of conditions are, floating and flowing and sort of acting on the city, and climate changes and these environmental effects of climate change are kind of driving these kinds of systems. So I guess what I guess if there's a kind of method, in some ways it's quite a kind of traditional kind of way of sort of thinking about catchments, which really goes back to Ian McHarg and Design with Nature, which you will have all read about and all seen. So what I'm saying is, well, we need to put the city into this kind of larger kind of structure, which we call a catchment. We need to kind of understand the hydrological structure of the catchment. Where water's going now, where water could be going. And there's a whole lot of tools we can use, like GIS. We can map catchments, we can map overland flow paths, we can map riparian margins, and then we can, and obviously using other software, we can actually start to understand, well, where's the water going to fall? Where's it going to? How much is going to fall? How much is going to be absorbed? How much is going to kind of run off? Where's it going to go? And so we can start to kind of understand where what is going to be the effect of this increased rainfall. So that's that's pretty straightforward. I think you'll I'm sure you've done lots of mapping, and obviously it's not good to put buildings in floodplains and put them in the middle of overland flow paths. That's all kind of straightforward. I guess the bit that also interests me, maybe it's slightly more difficult, and that is I guess the contribution that the city makes to flooding, or the contribution that buildings and impervious surfaces make. So flooding happens, and we can trace where it's going through topographic analysis, but by building more impervious surfaces, by building more buildings, we're also contributing to flooding, obviously. And so is there some way of understanding how much a new development is going to contribute to to these effects in the city? And that bit I think is very interesting, and I guess that's the bit I think if you sort of follow through the consequences, or if you kind of follow a logical kind of path, that's the bit where the actual urban model has to change. We can't build dense grid impervious kind of cities. Crudely, we've got to have more green space. We've got to have more open space in a city. We've got to have more, well, whatever you like to call them, parks or reserves or whatever. to not just direct the water, but to actually soak up the water. And so our building program, our development program has to get smaller. That impervious surface kind of has to get smaller and probably taller. And so, yeah, so hopefully kind of follow that sort of argument. We need to think about the city as a catchment. We use tools that we've already got to kind of map where water's going to go in the catchment, where water's going to flow, where the increased amount of water will accumulate. But at the same time, we need to understand the effect of maybe a new development and what the new development is, and the consequences of that new development in terms of contributing to an increase in flooding. Does that make sense? Questions so far?
No. Makes sense for sure.
Happy to take questions anytime, because talking. All right. So we place a development site within a hydrological catchment, and we can then understand the environmental effect on the catchment and on the urban form of this new kind of development. So I guess leading on from that, there's probably perhaps that's what I talk about in the book. There's probably 4 or 5 points which we could sort of start to kind of dive down into when we start diving down and thinking about the city, perhaps a greenfield site, maybe more than a brownfield site. But there are maybe 4 or 5 kind of points in which or methods or techniques in which we could perhaps use to help us rethink that city form and to protect ourselves, protect the citizens, because this is really, people, already, obviously in China, people already, are kind of already drowning in these sort of floods. It's going to get worse. People are it is going to be dangerous. People are going to kind of lose their lives. So I think once we kind of understand that larger kind of picture of where the flooding is going and what the effect of those impervious surfaces is going to be, then I think we can sort of start to think about some concrete kind of, I guess, landscape driven techniques to help us, kind of at least start the kind of development of a kind of urban plan. So the first thing would be that when we look at a catchment, we're looking to see if we can find any natural spaces within that catchment. There are some, there might be some, or there might be places where nature could be restored. Fragments, leftover spaces, areas which aren't being used. So it's really thinking about looking at what's in that urban catchment and trying to protect areas or trying to enhance natural spaces. I guess the next thing is really important is, again, in an urban area, this is kind of difficult. Maybe in a greenfield site, it's perhaps easier, but we're really trying to think about biodiversity. It's really extremely important. Terrestrial, aquatic biodiversity. So again, protecting, if you can find existing ecotones or indigenous habitats, protecting them. If they're damaged, perhaps identifying them, prioritizing your restoration, replanting, protecting riparian corridors, daylighting streams, all this kind of stuff. And then I think the next thing is really, using GIS is great, and with GIS we can kind of identify riparian corridors, we can identify overland flow paths, and it's really looking at those even in obviously greenfield site, but even in the city we can kind of identify them, we can understand them, and these need to be protected because these are the things that are going to kind of take the flooding. They're going to kind of take that water, and they're also help us with increasing biodiversities, being corridors for wildlife, flora and fauna, and so planting those areas, protecting those kinds of existing urban streams or daylighted urban streams or overland flow paths, which will become streams, with flooding. That's kind of a really important part of our of how we could start to build resilience in the city. And I guess the last two are really, maybe more kind of sort of in that kind of urban design territory. So obviously we want to reduce impervious surface, and that is, obviously buildings, houses, but it's also, roads and, paths and, certain kinds of urban spaces. We've really got to kind of reduce that. We've really got to kind of reduce that amount of impervious surface within the catchment, because that is also contributing to that flooding. And then lastly, a way in which we could perhaps reduce that kind of impervious surface is, and especially when it comes to building, is this kind of idea of clustering, or it has various kinds of names, but it's really thinking about, well, can we kind of pull that building program together? So this is for all the landscape architects there. That's all you can all become architects, and it's really kind of pulling these sort of building programs together, and just thinking about, do we need such a big footprint for this kind of building program? Can it be a smaller footprint, but maybe a kind of a taller building? And in that way we can. And in that way, I guess we can then obviously satisfy our friends, the developers, and the real estate people who we've got to keep happy, so they can still have their their building program, their real estate program. They can get the amount of saleable real estate that they need, but at the same time we can also satisfy this kind of need for more pervious surface, more open space, more green space, more space for overland flow paths, more space to soak up water, more space for trees and plants to kind of build biodiversity. So it's a kind of a swap, I guess. It's sort of a it's a kind of a negotiation between these things. The sort of desire, this kind of real, I guess we live in a capitalist economy, and so development is very important, but at the same time we have these kind of pressures from climate change. So maybe another urban model can help. Okay, hopefully that kind of quick, but that kind of makes sense. So I guess I looked at climate change. I looked at the compact city model, raised some questions about it, and then I guess put forward some ways, some techniques in which we can build a kind of city that is more resilient, and one that is and that one's safer for citizens. So I thought I'd just show a couple of projects in New Zealand, and one's a kind of I guess we call it a brownfield site, one's a greenfield site, and just show how some of these ideas, some of the techniques were kind of played out, and what the kind of results kind of were. So this is a site called Freeman's Bay. It's in Auckland, where I live, and this is the centre of Auckland, and it has the same. I'm sure, like you've seen a million places all around the world. It has a waterfront. It was an industrial waterfront, and it's now become a a new waterfront with bars, restaurants, the promenade, the hotels, the offices, the apartments, this real estate kind of transformation of kind of the waterfront. It's called Wynyard Quarter, extremely successful. So I was really interested in, I guess as a kind of a case study. Well, it's a great place. It's won all these awards. It's seen as being this kind of very successful place. But what's going to happen with climate change? What's going to be the implication for the site when we have these rainfalls, when we have these floods? What's going to happen to this development? So here's the site, and so I was interested. So the Wynyard Quarter is the kind of the bit down at the front where it says Silo Park. I was interested in the kind of the catchment. What was happening in that. What was happening in that kind of larger catchment. So here's what it looks like now. Very nice. Here's the plan. So you can see it's laid out in a kind of very typical development grid. So everything's gridded, has blocks, and you can, this block can be an apartment building, this block can be an office. Here's the promenade that runs along here, the restaurants and so forth. Here is what's going to become a park at the end. This is what it used to look like. So industrial site. It was called a tank farm. So it used to be covered in large tanks which held petrochemicals. But at the same time, the Freeman's Bay catchment, which is the bit I'll show you in a minute. I think I showed back here. This is a large catchment, 250 hectares. That Freeman's Bay catchment all ends up in one pipe, and that one pipe exits here. If you can just see my little arrow. And so when there's a heavy downpour, this basin turns kind of dark brown from all the pollutants in that larger catchment. So here we have this kind of award-winning urban design, promenade, restaurant, bars, blah blah blah. But environmentally, it's a disaster. And this is before climate change. This is before the effects of climate change. It seemed like a very interesting. A very interesting juxtaposition of kind of environmental conditions and urban conditions and urban models. So and then I just looking at kind of GIS mapping of the site, so you can see the site has this is already before climate change. The site itself has large areas of flooding on it. So where's that going to go? Sea level rise, obviously, it's pretty stuffed. So yeah, it just seemed like a really interesting, and this is not unique. Obviously, waterfronts all around the world have these problems. But it just seemed, I guess it just seemed like a very interesting kind of way of thinking, a very interesting kind of case study to think about how we might make that site more resilient to to climate change. So, and this is kind of the process. So reframing Wynyard Quarter as part of a larger catchment, Wynyard Quarter is 300 hectares, and then looking at what's impervious, what's pervious. So the whole site is 70% impervious. So that's the whole, inner city, that 300 hectares, which I'm sure is very typical of, most cities in the world by waterfront. I'm sure most cities in the world are pretty much impervious surfaces, so yeah, just doing some kind of modelling. This is the catchment. These were the building footprints in the catchment. These were the impervious surfaces, so roads and buildings. Pervious surfaces, so only a quarter of it is that. There's a very nice park here in the middle, but and actually there's one here as well. But yeah, obviously, as you can see, mostly impervious. And there, like I said, there's a drainage. So the whole drainage, the whole of this area, stormwater goes into essentially one pipe, and we also have a sewage. We have a problem with sewage as well. The sewage, it's a very old. This is an old part of the city, not as old as Istanbul, of course, but 19th century, and the sewage, the structures pretty had it, and so there's a lot of sewage overflow into the harbour as well in this pipe. So again, I'm sure typical of many cities. Yeah, just sort of thinking about, okay, so we're getting this sort of stormwater, sewage kind of going to the harbour. That's not such a great thing. Perhaps we should treat it before it goes in the harbour. Perhaps we should actually kind of do something to it. And so these are just some very basic kind of calculations. I kind of won't go into it, but it's just a simple kind of formula we have to size, just to work out how much stormwater needs to be treated, and then if we were kind of to use something like a wetland to treat it, how big would that wetland be? And so without going into all the details, we're talking about something like a 6 hectare wetland at the end of the pipe to kind of treat that water. So yeah, I guess what I'm I'm just really looking at one problem, but what I'm saying is, well, what I'm interested in is, here's this urban waterfront, which we all think is great and is great, very pleasant, but it has these kind of serious environmental problems. These environmental problems are going to get worse with climate change. How do we, what's some way of remediating them? Well, one way could be, let's put in a wetland and treat the water before it is discharged. So these are just kind of some simple sketches, some simple kind of models, and this is how big the wetland would be. So as you can see, it's not possible because of the real estate program, and so that's not kind of that's not really a possibility. But just sort of thinking about, well, maybe the wetland could perhaps go in this kind of other part of the development, and this part of the development was planned to be a park, and then there was going to be some kind of what do you call it? Iconic building. The Bilbao effect. We're going to have some kind of building at the end, and blah 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 blah. So that was. So again, just working through some kind of speculative kind of options about how how we can take this existing urban model, but in a way how we could ameliorate the worst of those environmental kinds of problems. Okay, so this is the sort of drilling down, this is the development plan for the site. So this is FAR, this is the FAR, which I'm sure you all understand. So this is, how developers develop a site. This is how much building they can put up, how high they can put it up, or how they can reconfigure the block. This is the bit that I'm sort of looking at. This is a kind of speculative, this is a proposal. This is how much building we would put on that site, and then the rest of it would be a park. Then they've done some more work on it as usual, and so this is the latest plan. So the park is now sort of here, and the building is now here. I'm sorry. These are kind of, the orientation's the wrong way around. But if you can see here, the park was on this side, and now the buildings are kind of on this side, and the park's kind of behind them. So that's the proposal. Okay, so I guess this little kind of series of slides is really a kind of a speculation about how an industrial site, which is being transformed into a into a waterfront, into this kind of leisure land, this leisure landscape, and also obviously a real estate kind of landscape, how this could be. How this could accommodate that real estate program, but at the same time ameliorate this environmental problem, and at the same time provide a kind of social space, a kind of a public space for Aucklanders, using some of these kind of ideas that I kind of talked about. So really kind of thinking about, well, the kind of the edge condition of the site, and that obviously we need to kind of protect the site from sea level rise. So perhaps it could be some kind of littoral condition. There could be a kind of restoration of a typical waterfront edge in kind of Auckland. And again, there's millions of examples of this kind of soft engineering, where we can protect the interior, but at the same time replant and reinvigorate the kind of native vegetation for that kind of edge. And then within the site, there's obviously a whole series of overland float paths, where water's kind of running on the site. So again, in some way protecting these, ensuring that they kind of can kind of work. And so in this scenario, kind of amalgamating them in some kind of way by buffering these kinds of areas, and then recasting the site as a kind of wetland. So I don't know if you remember, we needed something like 5 or 6 hectares wetland to treat all that kind of water. So just to remind you, all the water's coming out of a pipe in this corner, all the stormwater for that catchment is coming out of this kind of pipe in this corner, and kind of contaminating this area here. So rather than coming out here, just sort of speculating, well, perhaps this could be a wetland. That water, that contaminated water, could kind of come into this kind of area here. And millions of kind of examples of these sorts of urban wetlands, especially in China. And then that leaves some kind of bits of land that are left over, and thinking about the real estate program, and I think it was something like 50,000. I think it's something like 50,000 square meters of residential development that they're kind of planning for this kind of area. So this is what they want to do, and this is the kind of environmental kind of program. So buffering the edge, protecting the edge from sea level rise, building a series of wetlands which would treat that kind of stormwater from that larger catchment, and then in this kind of leftover land, clustering that 50,000 square metre building program into a series of isolated kind of buildings. So, you know, so I guess, you know, what this kind of speculative kind of experiment is sort of trying to do is trying to say, you know, can we have the social, you know, trying to have a social space for Auckland, the park, which is, you know, what we've been promised. Can we also satisfy the real estate program, which is, you know, for rich people to have apartments, and then at the same time develop an environmental program that is going to treat stormwater from that larger catchment so it doesn't go into the harbour, and then also protect the kind of the edges of this kind of scheme. So I guess, you know, what I'm trying to demonstrate is a landscape driven urban program, and one that's really driven by these sort of larger environmental concerns, especially around flooding and stormwater, and really remediating these kinds of features, and then finding solutions for these, you know, important, you know, these are important things in cities. Real estate's important, making sure, you know, people get real estate returns important, making sure people have public space which they can use. You know, these are all kind of important parts of a city. Okay, must be some questions.
I have one. What was the reaction of the real estate community as well as the municipality? Were you able to convince them, Matthew?
They think this one is great. You know, the one at the end, excellent. You know, that's going to be great to sell that one, no problem. The one, the block at the back, maybe not so much. I also did. There's also, you know, without labouring it, there's a thing called in Vancouver. They have a kind of a developer contribution. Does anyone know? Have anyone heard about this?
No.
No. And in Vancouver, you know, they have a kind of a policy of building tall buildings, tall skinny buildings, so you can kind of see through them to the views of the hills kind of around. And they're not really concerned. They have a certain height limit, but they're not super concerned about it. And so what they do is they actually say to developer, you can build more, you can build taller, but we take a development contribution. And with that development and with that contribution, they build art galleries and parks and so on. And so I actually did another project with this one to actually build taller, and then what exactly would the development contribution be? So this could actually be the actual, you know, the whole thing could be kind of could be built through development contribution. Yeah, so there's lots of interesting kind of possibilities. More questions, surely? No?
And can you give us a little bit about the role of the landscape architect in such a project that involves many different disciplines like hydrologist, civil engineer, mechanical engineer? I mean, without them, actually, we cannot realize our dreams. And there is definitely a difference in the paradigms. They are more on the engineering side and more on the gray side, and we are definitely on more nature-based and green side. And sometimes in our context, actually in Turkey, it's very hard to convince them about these nature-based solutions because they have this traditional way of doing things, although it's not working, and then climate change is making that those kind of engineering problems are not enough. Still there is a challenge to convince them here.
Yeah.
So what are your strategies? That is also a concern of a matter of strategy. So what is your strategy to communicate with them in a more efficient way?
Yeah, that's a very good question, and it's very much the same in New Zealand. You know that. Well, I'm not sure, but basic engineers. I'm not sure if it's the same in Turkey, but engineers kind of run all the projects. You know, run all the infrastructure projects, and yeah, they're definitely very traditional, and especially when it comes to stormwater, pipes are the answer, and we kind of put everything into a pipe. But I think there are, just speaking about kind of engineers that I know, there's, especially younger ones, there's definitely a kind of change in thinking, and I do think this is driven by climate change. I think I think all these kind of professional groups recognize that there is kind of that climate change is going to kind of ask for solutions which they don't, which traditional solutions aren't going to be enough for these kinds of challenges. And and increasingly, I'm not sure about in Turkey, but increasingly we've got legislation in New Zealand, environmental legislation, which is going to actually mandate changes to the way we design greenfield sites. We design, especially if you're designing anything near the coast, we've got probably like Turkey, we've predicted terrible incursion, sea level rise incursion, and so if you're an engineer or anyone or architect, if you're going to build in those areas, there's going to be questions of liability, and then on top of that, of course, there's insurance, and so insurance companies are just going to start to kind of walk away from projects, if they see that they're going to be threatened by climate change. These projects can't be insured, and so I think when these kinds of issues become monetarized, when clients, developers start to see that there's going to be kind of consequences that they're going to have to pay for themselves, or they're going to become liable for, then they're going to be looking for kind of larger solutions. And I think some of the bigger, more innovative engineering companies are definitely kind of thinking along these lines. I was talking to some colleagues who are working for WSP. It's a big international engineering company, and they're talking about how WSP are talking about going, climate carbon zero. So these big engineers are actually kind of talking this kind of language, and they're talking about actually kind of actually looking at carbon budgets for projects, and then carbon budgets for their own practices. So some of these big companies are actually kind of looking at, well, how do they actually kind of run their office? They even kind of it's amazing. They're even kind of looking at what sort of car are people driving. So they're very, I think they're becoming more and more conscious of these kinds of issues. And sorry, I'll just one more thing. And I guess I think this sounds maybe a little bit mercenary, but I think professionals can see that that climate change is going to be the big issue for professionals, so landscape architects, for architects, for engineers. That's really where the work is going to be in the future. And this is for all you guys. That's where we're going to be working in that kind of area. And the budgets. I know this sounds a bit capitalist, but the money is going to be enormous. So I think a lot of these big practices are already kind of looking at that and going, well, how are we going to kind of how are we going to help governments? How are we going to help local governments? How are we going to help NGOs? What sort of techniques are we have we got? Are the ones we've got at the moment, are they working? No. Are they going to work in the future? No. We've got to think of some new ways of building. We're going to think of some new ways of developing. We're going to think of new ways of building housing, of building cities, of building malls, of building these things. I think they all realize the first person who kind of comes up with an innovative way of doing this, which can also be monetized, is going to get a lot of work. There's going to be a lot of professional work. So sorry, that's a rather long-winded answer, but
oh no.
Yeah.
No, it will take time. I mean, we have to be patient. I mean, as landscape architects, we want to change the world the next day, but it's not going to happen. It's going to take more disasters and more crises probably until the whole world comes into the certain understanding. But we cannot give up, and we have to do our best as fast as possible under any kind of circumstance. So are there any other questions? I would like to open the floor for your questions. There is a chat box comment there. Okay, Eda says, I agree. I think everyone is aware of those ecological problems, wants to work together, but there is no healthy communication and governmental help. And we have a colleague says that he has to go to his class, and thank you for your presentation, Matthew. And he was listening us from another university, another city. It's like a open house presentation seminar for us today.
Cool.
And I just want to thank you, Matthew.
Anybody?
Oh, no worries. No worries.
For the great presentation and the great work, and our students is also here, so you give them courage. Because it's a realization project, and they are working on the river corridor project in their studio. So thank you so much for your great work and the great presentation.
No worries, and I'll send you my email. I'll put it in the chat, and really happy if anyone wants to write to me, there's no really happy to kind of there's kind of no problem. I really do think I mean, I know it's kind of it does seem like hard work at the moment, but I really do think landscape architecture is the kind of the profession of this century. I think we all have the tool. We have these tools. We know these sorts of things. We sort of think everyone else knows them, and no one does. But they really need these. They really need these kind of techniques and tools that we have. And I think it's. So I think I'm not quite sure what your profession is doing, but in Australia and New Zealand, we're making really a big push in our profession. We're publishing series of documents. I can send you the Australian ones. They're really extraordinary kind of documents of sort of laying out. So it's laying out, and they're sort of documents you could send to the engineer, to the architect, the local council, and just say, look, this is what's happening. Climate change is happening. These are the things that we are doing. These are some case studies that we have done. So practical suggestions, practical techniques, things that you can kind of that you can kind of do. So on that level, I think all of you can do that, and you can all. You're all good at social media. Just go on social media and just start showing people projects.
Exactly. I think this is what we need to do. We need to share more of our experiences, and we need to share more of the thoughts that's sustainable and ecologically sound. But I was wondering, do you guys have legislations? All these hard work, because I'm following like the Australia, New Zealand, and you have really strong documentations and really good work coming from that geography. Are they in the legislations somehow now, Matthew?
Legislation is definitely coming. I can send you some links. But yeah, in the next couple of years, there's going to be some really strong legislation around climate change, and in particular, retreat. Sorry, sea level retreat. That's a big issue for us. And so, exactly, you know, how's it going to happen? Compensation. You know, there's a whole kind of area in there.
Right.
Yeah. I mean, I just going back to that social media thing. I mean, you know, I'm not, obviously I'm no expert, but you know, I just, like, I'm on Twitter and someone says something and I just sort of send them links to a project. You know, this is how someone's done something. You know, this is how they've dealt with flooding. This is how they've dealt with stormwater. You know, it's all, you know, some projects in Auckland, someone's building in some development in a floodplain. You know, I send maps. I send the flood maps, the GIS flood maps. And go, is this a good idea? You know, it's just about saying what we do. You know, just kind of putting our stuff out there, and then I think getting involved in your institute, and I'm not quite sure what they're like, but you know, pushing them along with climate change, and then just getting involved. You know, being advocates. It's really important being kind of an advocate for the profession, and you know, it's not. I don't think it's pushing yourself. It's just saying, look, this is what landscape architects can do. This is how we can help. You know, I think that sort of level.
Right. Well, thank you very much, Matthew. Our time is up, and it was very thought-provoking presentation. It's always good to see that we are seeing things eye to eye around the world as the larger landscape architecture community, because sometimes in Turkey we feel alone and kind of like down, but seeing the examples and then the way the parallel thinking process around the world keeps us believing that we are in a right track. We know the good things, and we have to do or apply different strategies to communicate more efficiently. I mean, it's not that we are lacking the information or the knowledge or the science, but we have some problems with the way we communicate with the current status quo. So thank you very much for sharing your experience in your part of the world, and we are really looking forward to the studio exchanges again, and maybe in such a topic, because our department puts a great emphasis on the climate change and how are we going to deal with the heat island effects or seawater rise or really long droughts, but then all of a sudden huge floods, those unpredictable weather events. So there are a lot of topics that we can collaborate and do a joint studio now that we learned this Zoom environment and teaching online and communicating with the world. We should take advantage of it.
It's fantastic. Yeah. No, really happy to talk. Well, maybe offline, but yeah, we're looking at a project next year, kind of a urban stream project, plus sort of housing. So maybe we could talk about that and talk about times and things. Yeah.
That would be great. That would be great. Thank you very much, Matthew. Always pleasure to work with you. Thank you very much, everyone. And this is the final presentation of the semester of the year. And with that, I would like to give my best wishes to everyone for a new year and happy and healthy, prosperous 2022. Take care. Bye-bye, everybody.
Thank you.
Thank you, Matthew, again. Bye. Have fun.
Thanks again. See ya.